So friends, example number 11.4, the question is given, what is the work done? So question is to find work done to increase the velocity of a car, to increase the velocity from 30 km per hour to 60 km per hour. So these are two different velocities given to you. First is mass is given, mass of car is 1500 kg. So this is nothing to change because kg is assigned it, and two velocities are given and the mass of the car 1500 kg is there. So friends, first velocity is we consider as u, that is initial velocity, and initial velocity here is given 30 km per hour. Now the question is that this unit of this velocity is not SI unit. So we have to convert it into the SI unit, meter per second. Meter is the unit for length or distance and second is for time. So friends, we have to convert this value in meter per second. So how is it possible? So U is equal to 30. 30 kilometer is there, and 1 kilometer is equal to 1000 meter. So here we have to multiply it by 1000. And per hour, per means in 1 hour. So this is 1 hour. So 1 into 60 minutes and into 60 second. So this is 60 minutes, 60 second. Total 1 hour has 3600 seconds. So this is written like this, meter and second. Now unit is there. You can see this is 0, 0, 0, 0 cut, right? 3 to the, and this is 100 by 12 meter per second. If you go for some more changes, you will get it is 25 by 3 meter per second. This is the initial velocity we can get from the 30 km per hour. Similarly, friends, final velocity is called V, and final velocity value is 60 km per hour is given. If we convert it into meter per second, 60 into 1000, this is meter. Once again, 60 into 60, it's second. So this is simple, 60, 60, this is 0, 0, and like finally we get 50 by 3 meter per second. So this is the value of V we obtain. This is, we give the number 2. So here, after changing the units, which is the most primary thing for any numerical, you have to convert the units as per the requirement. Now V, U, and M, both of all of these things we have. So what to do now, friends? We have to find the work done. To find work done, that is change in the kinetic energy. That is called work done, friends, for moving objects. So work done is equal to final kinetic energy minus initial kinetic energy. So this is important one. Final kinetic energy is by considering value of EK. EK is formula for kinetic energy, and if I write here I for initial. So initial kinetic energy, for that the formula is 1/2 mv square. No, it's mu square, because here initial, so initial kinetic energy is to be taken when we want to find out the initial kinetic energy. Initial velocity is to be taken, and when here it's 1/2, this is 15 kg, mass is given here in the question only. Okay, and then u square. U is already here 25 by 3. So 25 by 3 one time meter per second into once again 25 by 3 meter per second, because its square is to be taken. Friends, if you convert this into simpler form, you will get the answer. Answer is, friends, 156,250 divided by 3 joule or meter per second. Friends, this is still is to be used in the another one, and that's why its simplification is not required here, because our question is to find work done, not is to be find initial kinetic energy, and that's why we are not converting it into the simplest form. Finally, second one, EKF, that is final kinetic energy. For final kinetic energy, we have to put the formula 1/2 mv square. 1/2 m is once again 1500 kg, and value of v, velocity, this is 50 by 3. So it is to be taken two times, 50 by 3 meter per second into 50 by 3 meter per second. So here also, friends, by considering the simple changes, we obtain the values 625,000 by 3 joule. This is final kinetic energy. So two kinetic energies we have. One is initial and another is final. So to find work done, we have to take the subtraction of these two. What happened there? So work done is equal to EKF. F is final and EKI, I is initial. Final is what? Final is 625,000 by 3 minus, friends, this is 156,250. So 156,250 by 3. Simple thing is that the 3 is the LCM, and when you subtract 625,000 minus 156,250 by 3, you will get the answer 156,250, and this is work, and work also has the same unit, that is joule. So what we have done, the most important term, that is conversion of the units from kilometer per hour to meter per second, that is done here. One thing. Second important thing, friends, is done here is about to find the initial kinetic energy and the final kinetic energy. Both are independently done, and then after for to work done, this is final kinetic energy minus initial kinetic energy is done, and the final answer we obtain this. Okay, friends.